Hello, this is Miller's Pre-Calculus class. The topics we're going to discuss in this lesson are radicals and exponents. We're going to go from a radical form to an exponential form, and the other way also. We're going to expand logarithms, we're going to condense logarithms, and we're going to rewrite a log in the exponential form. And these are used to solve different types of problems, such as chemistry problems, physics problems, geology problems. This is all stuff that's based in the real world, some of the time.
So my first set of problems, what I want to do is convert this from exponential form to radical form. So that's going to equal some radical type problem. So I'm going to put a radical, not a square root, just the radical. Something's going to go inside of there. And I'm going to put that x inside. Now I like to use this little memory mnemonic, and I'll ask myself, what's on the bottom? And notice that 3 is on the bottom, so I throw that 3 in this little bucket. That's actually called the index. And then the exponent can either go here or outside. I prefer to put it inside. Either one is correct. So that answer, written in radical form, is the cube root of x squared. Once you get the hang of it, it should go pretty quickly. So I'm going to write this from an exponential form into a radical form. So I'm going to put a radical symbol. I'm going to put the x inside the radical. And then I notice what's inside the bucket is going to be what's below, what's on the bottom. The 7 is on the bottom, so the 7 goes inside the bucket. And then the 5 is going to be the exponent. So I put the 5 up there. So the answer is going to be the 7th root of x to the 5th. X to the 1/2 shows up quite often. We just don't recognize it. I'm going to put a radical. I'm going to put the x. Now this is kind of strange. I could be done. That could be my answer. But hidden inside of that index, if I don't put anything there, there's a hidden 2. And then up here, we know that's x to the 1st. So the actual answer could also be just the square root of x. And the hidden 2 is implied. X to the 1/4. I'm going to write down my radical. I'm going to put the x inside. Notice the 4 is on the bottom, so the 4 is going to go in the bucket. So that's now the 4th root of x to the 1st power. I don't have to put the 1 there, but it's okay if I do. So it's the 4th root of x to the 1st. So now we're going to go the other way. We're going to go from a radical to a rational exponent. So I'm just going to write the x down and then some fraction. Now I have to figure out what goes on the top of the fraction, what goes on the bottom of the fraction. What's in the bucket? Notice the 3 is in the bucket, so the index goes on the bottom. And then the 4 is going to be the top or the numerator of the fraction. This is actually more useful to write it from radical form to rational form, because now we can take a derivative of that in calculus. So this algebra move is needed in calculus sometimes. I'm going to rewrite this as x to some fractional exponent. And then let's take a look. Notice that the 5 is in the bucket. So what's in the bucket, what's in the index goes on the bottom, or the denominator. And then this exponent is going to be my numerator. And that's it. What we're going to do here is expand the logarithm, and ln is considered a logarithm. It's considered the natural log. So notice I have 3 items, x, y, z. So I'm going to write the word ln 3
times. ln, ln, and ln. And then I put in the x, the y, and the z. And if it's multiplication, what the logarithms do is they break it down from multiplication to addition. So because I'm multiplying these, I'm going to add all three of these. Technically, I can put a plus sign in front of the ln x, but it's not necessary. Notice I have three items, 5xy, so I'm going to write the word log 3 times. Log, log, log. 5xy. And notice again, I'm multiplying everything, so they each get a plus sign. A log base 2, a 5xy divided by z. So notice I have 1, 2, 3, 4 items. So I'm going to write the word log base 2 1, 2, 3, 4 times. Log base 2, log base 2, log base 2, log base 2. 5xyz. 5xyz. Notice the 5 is on the top, so I can technically put a plus sign because I'm multiplying that. X is on the top, that gets a plus sign. Y is on top, so that gets a plus sign. And the z, notice the z is on bottom, so logarithms change a division down to a subtraction. And that's your final answer. However, you don't need the plus sign. I have three items, x, y, and z. So I'm going to write the word log 3 times. Log, log, log. Now this one's a little bit more involved because it has all these radicals. X, y, z. Now I'm going to technically rewrite that x, that square root x, in exponential form. So that can be rewritten as x to the 1/2. And that 1/2 is going to get ripped out in front. So it's going to be 1/2 log of x. This here, the cube root of y squared. I can rewrite that as y to the 2/3. But instead of putting the 2/3 up in the exponent, I'm going to bring it out front of the log. Then this is z, the cube root of z. I can rewrite that as z to the 1/3. And instead of putting that 1/3 as the exponent, I put it as a leading coefficient. Notice the x is on top, so it's going to be a positive 1/2. The y is on top, I'm multiplying it. So that's going to be a positive 2/3 log base 10 of y. And the z is on the bottom, it's divided, so that gets changed to subtraction. And what the logarithm does, it'll break a multiplication down to an addition. It'll break an exponent down to a multiplication. It'll break a radical down to a fraction. It'll break a division down to a subtraction.
It's going to be one term, a single.
Logarithm, or a natural log, ln. And then I look for any minus signs. Notice there's a minus sign. As soon as I see a minus sign, I put a fraction bar. And then whatever's being added goes on top of the fraction bar. That's a positive ln x. So the x is going to be on top of the fraction bar. Plus ln y. Plus ln z. The z goes on top of the fraction bar. Minus ln2. The negative gets brought up to a division symbol. So that's going to be divided by 2. The negative ln w, that means divide by w. And there's your single logarithm. I condensed it. Number 12. Notice I have log written 3 times. I'm only going to write it 1 time. Log base 2. Notice the minus sign. So I'm going to put a division bar. X, y, they both have positives out in front, so they go on top of the division bar. The 1/2 z, the z goes on the bottom because it has a minus out front. And because there's a fraction, that's going to be a radical. That 1/2 would actually get kicked up to there. Now I want to rewrite it in radical form. So the 2 is on the bottom, That goes in the bucket. And the exponent's 1. I can rewrite this as log base 2 of xy over just the square root of z. I don't need the 2, I don't need the 1. Either one is correct. I'm going to write the word ln just one time. I see a minus sign, so I put a division bar. 5 goes on top, x goes on top, y goes on bottom because there's a minus sign. 4 goes on bottom because there's a minus sign. The 5, I can re-raise that to the 1/2 power. And then I'm going to rewrite that as a radical. I can put the 2 in there, but I don't have to. The x has nothing but a 1 out front, a positive 1, so I can leave that. Now the ln y, the 1/3, I'm going to rewrite up here as an exponent, and that's going to give me the cube root of y to the first. And 4 gets left alone. I'm going to write the word log one time. I see a minus sign, so I draw a division bar. X goes on top, Y goes on top. They both have a positive in front. The Z goes on the bottom. It has a negative in front. The X gets raised. This 4 gets kicked up to a power. What a logarithm does is it breaks down an exponent to a multiplication. It breaks a multiplication down to an addition. So I want to rewrite this as x to the 4th now. I'm going in the other direction. The log y, there's a hidden 1 out front, so that's going to be y to the 1. I don't have to write that. The 3 gets kicked up, so that's going to be z to the 3rd power. I write the word log one time. I see a minus sign, so I put a division bar. A goes on top, B goes on top, X goes on the bottom. The 2 gets kicked up as an exponent, so that's going to be a squared. The 3 gets kicked up as an exponent, so it's going to be b cubed. The 1/2 gets kicked up as an exponent, but we rewrite that, x to the 1/2, as the square root of x.